Welcome to this solution video which has been demanded by one of my subscribers. In this question number 1, a crane is used to raise a block of mass 50 kg vertically upwards. So let's say this was here and it was raised to upper level, okay, at a constant speed through a height of 3.5 meters. So the height here is 3.5 meters. There is a constant resistance to the motion of 25 newtons. So there will be a force of resistance downwards. That's why the work will be done by this resistive force. Find the work done by the crane. Alright, so we can use the energy formula here. Delta kinetic energy plus delta potential energy, difference in kinetic and difference in potential energy, equal to work done by the applied force minus work done by the resistive force. Okay, it was stationary here when obviously whenever we pick up something it is initially at rest, and when you put and keep it somewhere else again it is at rest. So there has been no change in kinetic energy, so we will say 0. Now change in potential energy is there because it has been raised by 3.5 meters. So it will be m is 50 kg, g and h final, which is 3.5 meters. Yeah, finally it is 3 meters high minus height initial. It was initially at the ground level. So this is delta PE equal to applied force. We want to see how much work was done by the applied force, the person who picked it up and put it there, minus work done by the resistive force. And we have a formula that work is force multiplied by the distance in same direction. Force is 25 Newton and the distance it took the object up, though resistive force it tried to stop it, right? So the distance it tried to stop is 3.5 meters. And now they're saying find the work done by the crane. So applied work, that's what they're asking. So let's move this to the left side with the rest of it. It will become 500 times 3.5, which will be 31750. Yeah. All right. Plus this will also come to the other side, which will be 25 times 3.5, 87.5 equal to work done by applied force. And if we add these two, we get 1837.5 joules. And since we usually round it up to 3 significant figures, so it will be 1840 joules. This is the work done by the crane. Alright, second part. Given that the time taken to raise the block is 2 seconds, find the power of the crane. So power is the work done by the applied force divided by the time it takes, and straightforwardly it will be 1000, rather we will use the one we used earlier, 1837.5. Later we can round it off, but initially we should use the actual time. Okay, so it is 918.75 watt, and we can say it is 919 watts approximately. All right, what is the next? Question number 2. The diagram shows a small object P of mass 20 kg held in equilibrium by light ropes attached to fixed points. So we can see, let's try to visualize this. So that means this rope is attached to some ceiling, this rope is attached to some wall, and there is a mass of 20 kg hanging here, so that these two ropes are taut. So let's say that T1 is the tension in this rope and T2 is tension in this rope. They are different ropes, so they will have different tensions. Okay, the rope PA is inclined at 50 degrees and the other one is at 10 degrees. They have shown it only in the drawing. Okay, find the tension in the rope PA and tension in the rope PB. Basically T1 and T2 they are asking us to find out. All right, So let's first convert them to components. So let's write the component of T1 first. In this direction, it will be T1 cos 50. Wherever is the angle, that component becomes cos component. Okay, and the other side here, upside, it will be T1 sine 50 degrees. Similarly, this will be T2 cos 10 degrees, and downwards will be T2 sine 10 degrees. But since this is hanging, it will have its own weight, and that means we will have the weight of P also downwards, and which is how much? 20 kg, so weight will be 200 newtons. Okay, and we know that this particle P is going nowhere. That means the horizontal forces are balanced as well as vertical forces are balanced. So let's make equation with the horizontal forces first. So T1 cos 50 will be equal to T2 cos 10. They are in opposite directions, they will be equal. That's why P is not moving anywhere. So let's isolate T1 in terms of T2. So T1 will be T2 cos 10 over cos 50. I'm not evaluating them. I'm not writing the values of cos 10 and cos 50 because I want as accurate as possible the solution. All right, let me write equation for the vertical one, and I need more space. I will do it here. So vertically we have T1 sine 50 will be equal to the sum of T2 sine 10 and 200 newtons. These two will balance T1 sine 50. And now let's put the value of T1, which was T2 cos 10, this one. T2 cos 10 multiplied by sine 50 and divided by how much? Cos 50. Okay, equal to T2 sine 10 plus 200. We want to find the value of T2. So let's take T2 to the left side, this one, and take T2 common here. So T2 taken common, we are left with what? Cos 10 sine 50 over cos 50, and this sine 10 will also come to the left side but become negative. It is positive here. When it comes, it becomes negative, and T2 is already out, so I'm not writing T2 again, is equal to 200. And now if I add 2T2, it will be equal to 200, and this whole thing will divide this. You can evaluate this, but I'm writing the whole thing here so that there is no chance of getting an answer which is little off. So you will have to be very careful while putting this in your calculator. But yes, if you're not confident, you can do it part-wise. Do evaluate everything and you'll get it. Now, if I put this cos 10 sine 50 divided by cos 50 and then minus sine 10, I actually get 1, almost 1. So it becomes 200 divided by 1. And that's why the tension T2 is 200 newtons. Done. Now we have to find T1, and we had an equation for T1 already, which is this one. If you look, it was not here, it was on the drawing. Look here, this one, T1 equal to T2 cos 10 over cos 50. T2 is 200 already, so it will be 200 cos 10 over cos 50. Just put this in calculator and you'll get your answer. Let me do it myself. By the time I do this, I would request you to subscribe to my channel and like and share this video with your friends. You can demand some solution video. I will prepare it for you, and everybody will get benefited. Thank you very much. So after using my calculator, I got 306.4 newtons. So we can again round it off to 3 significant figures. We can just write 306 newtons. Let's move on to the next question. Particle P and Q of mass 7 kg and 3 kg respectively. That means this one has 7 kg, this one has a mass of 3 kg. Alright, are attached to the two ends of a light inextensible string. We can see that the best thing is that there is nothing in between that would make it difficult. So they are simply hanging on each corner of the table. Okay, the two particles are both initially at rest. Okay, U is 0 for both. And both are initially at rest 0.5 meters below the level of table. Okay, you can see this is 0.5. That means this length is also 0.5 and 0.4 meters above the horizontal floor. So this is also 0.4 meters above both of them. They have marked only here, but it is also there. Find the acceleration of the particles at this and the speed of p immediately before it reaches floor. For acceleration, we can use the general formula for forces. F net is always equal to applied force minus resistive force. F net is mass times acceleration, right? Since we are using both the masses, because both the masses are moving, so we'll use both the masses as a system. So 7 kg and 3 kg, 10 kg is the total mass times acceleration we want to find out. Applied force is the weight of 7 kg, which is 70 newtons in this direction. This is the force which is trying to drag the other mass to this side. So 70. And the weight of this Q will try to stop. It will resist the motion because the motion is in this direction, but its weight is in different direction. So we will write 30 newtons here. So what does we get? So what do we get as acceleration? It will be 10a equal to 40. So a will be 40 divided by 10, which is 4 meters per second square. That's the acceleration. They're also asking what is the speed of p immediately before reaching the ground here. So we know that the distance it covered from its original position to the ground will be 0.4 meters. That is the distance it covered. So we will use the formula, which is v square equal to u square plus 2as. So v square, we want to find v, it will v square. Initially it was at rest, the whole system, it was released, so 0 square plus 2 times acceleration we know is downwards 4 meters per second square, and motion is also downwards, so it's okay. S, we know it covered 0.4 meters to reach the ground. So now v square will be equal to 8 times 0.3.2. So v will be square root, we'll square root both sides, which is approximately 1.79 meters per second. Let's go to the second part of this. Determine whether Q comes to the instantaneous rest before it reaches the pulley. So since we know that it came down by 0.4 meter, that means Q will also go up by 0.4 meters, same, because they are connected by a tight string. So suppose it reaches here. So it is already 0.8 meters above ground. That means the distance it has to travel more to reach the pulley is 0.1 meters, because it is 0.9. Can you see? 0.5 plus 0.4 is 0.9. It is already reached 0.8, so 0.1. The question is, will this Q be able to cover this 0.1 meters? Let's see. So we will use, for second part, we will use the same method, same formula, v square equal to u square plus 2s. All right. There is nothing that is pulling the Q anywhere. It is just going up because of inertia. It reached here, it has to go a little further, right? So there is no acceleration in this direction now, but there is only one acceleration, which is downwards minus 10 meters per second square. So acceleration is minus 10. Distance, let's find out how much distance it travels. To u square will be the v square, which was in the previous stage 3.2, right? Because we are counting after that, and we want to see when will it stop. Yeah, it will stop. Finally, it will stop because there is no force pulling it anymore. So let's see how much distance will it travel to stop. So 0 equal to 3.2, and this will be minus 20s. So 3.2 comes to this side, 3.2 negative equal to minus 20s. So s will be minus 3.2 over minus 20. Both cancel out. 3.2 divided by 20 will be 0.16 meters, which is more than 0.1 meter we wanted, 0.1 meter. That means it will not stop before reaching pulley. The particle Q will not stop before pulley. That means it will collide with the pulley. Here is the next one. Ball A is released from rest from the top of a tower. So let's draw the tower. So suppose this is the tower. 1 second later, another ball B is projected vertically upwards from the ground level. So another was projected up. Speed was 20 meters per second. The previous one was dropped from here, just dropped, released. So its initial velocity is 0 meters per second. The time difference between them is 1 second. That means this is in air 1 second extra than the lower one B. All right. The two balls are at the same height 1.5 seconds after the ball B is projected. This is B. So 1.5, it has reached here. And 2.5 seconds later, it has reached here. Why 2.5 seconds? Because it was released 1 second before this. This was in air 1 second extra. So that has to be added here. Part 1 asks, show that the height of the tower is 50 meters. So if somehow we find this distance and this distance separately, can't we find the height? Because height is the sum of the two. So let's call it S1 and let's call this S2. So S1 is UT plus half AT square, right? U is 0 for S1. So S1 is 0 and there's no need to multiply by T, plus half, and it is moving down, and acceleration is also due to gravity downwards 10 meters per second square, and time is 2.5 square. So this and this cancel. So S1 is 5 times 2.5 square is 6.25, which is 31.25. Okay, let's say S2. What is S2? Same formula. S2 will be UT. U is 20 meter per second, its initial velocity. Time is 1.5 seconds, not 2.5 seconds, plus half, but this time acceleration is in opposite direction of the motion. It is going up, but acceleration is down as usual. So 10 and 1.5 square. Okay, so this becomes 30 minus, because 2 and 5 will give us minus 5. So minus 5 times 1.5 square will be 2.25. So 30 minus 11.25, yeah, which will be 18.75 meters. So height of the tower is S1 plus S2, which is 18.75 plus 31.25, and obviously it has to be 50 meters. We showed it. Okay, let's see what is the next part. Find the length of the time for which ball B has been in the motion when ball A reaches ground. For the time. So what we will do, the plan is that the ball started from here and reached here in certain time, correct? So after after 1 second, this ball was thrown up. So whatever is this time taken by this ball to reach ground, we will subtract 1 second when it was not thrown, and rest of the time it will be in the flight. That's what we will do. So let's find time. So we know now 50 is the total time covered by the ball A to reach ground, right? Because tower's height is 50. Again, U is 0, time we don't know, plus half, and acceleration is 10 downwards, t square. So it cancels out. So what do we get? This is second part of the question, okay? So 50 equal to 5t square, divide both sides by 5. So t square is equal to, this cancels, 10. So t, square root both sides, we'll get plus or minus answer, but time cannot be negative, so we'll write just the positive. Square root of 10 is about 3.16. So it took the ball A to reach ground in 3.16 seconds, but one of these seconds, the first 1 second, the ball which was lower was not thrown. So the ball B is in air for 3.16 and minus 1 second, which is 2.16 seconds. Hence, find the total distance traveled by ball B up to the instant when ball A reaches ground. Alright, so in other words, they're saying in 2.16 seconds how much distance is traveled. It would be straightforward if it goes there and it has not reached its peak, and we'll find the distance, right? But 2.16 is a long time. It is possible that it turned back. Sometime it went up and sometime it went down. So because they're saying distance, not displacement, that means we have to find two distances. One, how much distance, total height it took, and how much it came down in 2.16 seconds. So let's see how much time was taken to retain its maximum height. So we know that V equal to U plus AT. V was 0. When any body which reaches its peak, it stops there. So V is 0. U, initial velocity was 10, and acceleration is minus 10 in opposite direction, and time. So minus 20 equal to minus 10, divide by minus 10 both sides. T is 2 seconds. Yeah, as expected, out of 2.16 seconds, 2 seconds it took to reach its peak, and then 0.1 seconds, remaining 0.16 seconds, it came down. So again, let's find the distance. Let's say distance d1, and we will use the same formula again, s equal to ut plus half at square. U is 20, time we know now, 2 seconds it reached the peak, okay, plus half, it was thrown up but the gravity is downwards, and then 2 square. So d1, distance 1 is 40, and this cancels, minus 5 times 420. That means 20 meters was the total height it gained in first phase. Now 0.16 seconds is the time when it reached downwards. So let's find by the same formula, but this time we'll write it as d2. Okay, u is 0 this time because we are saying this is the initial position from where it is coming down. So initial velocity 0. Time 0.16 plus half. This time 10 will be positive because motion is in the direction of acceleration, and 0.16 square. All right. So this is 0 and this cancels this. So d2 comes out to be 5 times 0.16 square will be 0.0256. So it will be how much? 128 here. Yeah. It will be 0.128. So D1, it went 20 meters up and 0.12 meter down. So the distance will be 20 plus 0.128, which is 20.128 meters. Three significant figures we have to round off, so it will be 20.1 meters. A particle P starts from a fixed point O. Let's say this is O. It starts moving in a straight line. After t seconds after leaving O, the velocity v is this. So v equal to 6t minus 0.3t square depending on time. The particle comes to instantaneous rest at point x. So suppose this is the point x, here v is 0. Find the distance OX. So nowhere in between it comes to rest. That's what they're trying to tell us. So what will we do? We will write V equal to 0 and try to find out the time when it is at rest. So make it is equal to 0. So 6t, we can take t common here. 6 minus 0.3t. So that means t is equal to 0 and 6 minus 0.3t equal to 0. So at the starting itself, we know displacement is 0, velocity is also 0 because we got it here. And what about this? 6 equal to 0.3t and divide both sides by 0.3. We get time equal to 20 seconds. So it reaches x at t equal to 20. Now they're asking us to find the distance OX. For distance we need a displacement equation, and displacement equation we'll get by integrating the velocity equation, which was 60 minus 0.3t square. We'll integrate this with respect to time. Alright, so it comes out to be 6 t square over 2 minus 0.3 t cube over 3, yeah, plus c. Now we know that at t equal to 0, s is 0. So we can put it here. This is s. So s is 0 when t is 0. So 6 times 0 square, everything, even though it cancels out, it will be 0. 3 and this also cancels out. But because of this t cube, it is 0 plus c. That means c is 0, it is insignificant. Our equation for displacement becomes s equal to 3t square, that's what we got here, minus 0.1 t cube. And now we want to find distance till x from 0. So there is no need to write here 0 to 20. We could have done that, but since it's a straightforward question, we can substitute just 20 here. S equal to 320 square minus 0.1 20 cube, not 0.t. Okay, so 20 square is 400. 400 times 3 is 1200. Minus, it is 8000 times 0.1, 800. So 1200 minus 800 is 400 meters. The distance OX is 400 meters. Okay, what about the second part? A second particle Q starts from the rest from O at the same time as P. So we know this is the path for P from O, and we'll get for Q also. This is the particle Q and it also goes there. Alright. Also travels on a straight line. The acceleration is this. So acceleration equal to K minus 12T for Q, where K is a constant. The displacement of Q from O is 400 meters when time is 10. So it is 400 meters away. P was 20 seconds away from O, and then it reached 400 meters. It is within 10 seconds it is reaching there. All right. They're saying find the value of K. Okay, so let's integrate this one to find the velocity. Okay, so why? Because we need to go to displacement ultimately. So integration of acceleration will give us velocity, which will be equal to integration of k minus 12t. Integration of k, just k is a constant, will be kt minus 12t square over 2 for the second one, and constant c. This is the velocity. Now to find c, they have written that it starts from rest. Yes, so we will use v equal to 0 when time was 0. So k times 0 minus, this cancels out, 6 times 0 square plus c. So that you can see everything is 0, so c will be 0. Our equation for velocity is kt minus 6t square. Alright. Now, question was about displacement. So, for displacement, we'll integrate velocity equation again. So, kt minus 6t square dt. So, s will be, integration of kt will be kt square over 2 minus 6t cube over 3, and let's use a new constant d. Let's not confuse with this c, okay? So we know that at t equal to 0, s is 0. Yeah? So we can use that to find this d. So s is 0 when k 0 square over 2 minus 3 and 6 can cancel. 2 0 cube plus d. Again 0 0 0, d is also 0. Now our equation for displacement becomes kt square over 2 minus 3t, no 3, 2t cube. 2t cube. Alright? Now to find k, they have given a situation that at t equal to 10, displacement is 400. Displacement is 400. That means we will write 400 here. K time is 10 square 2 minus 210 cube, right? So 400 equal to 10 square is 100, divided by 2 will be 50. So 50k minus 10 cube is 1000, so 2000. Let's bring it to the left side. It becomes 400 plus 2000 equal to 50k. And let's complete it here. 400 plus 2000 will be 2000. 400 equal to 50k. And divide by 50 both sides. So that 50 cancels off here. K comes out to be 240048. That's the value of k. What's next? A cyclist is cycling with a constant power of 160 watt along a horizontal straight road. There is a constant resistance of 20 newtons. So there is a resistive force of 20 newton. Power is 160 watt. At an instant when the cyclist's speed is 5 meters per second, his acceleration is 0.15 meters per second square. Show that the total mass of the cyclist and the bicycle is 80 kg. All right, so since mass is involved, let's use, and forces are also involved, let's use F net equal to MA equal to applied force minus resistive force. Mass we want to find, so let's write it mass. Acceleration is given to us 0.15. Applied force we don't know yet, but we know resistive force is 20 Newton. So let's find applied force. We know that applied force is power divided by the speed with which the body is moving. Power is given to us 160. Speed is also given to us, that at that instant is 5. So it comes out to be how much? 32 newtons. So we'll use this 32 newtons here. Okay, so mass becomes 32 minus 20 is 12. Divide by 0.15, and which is definitely 80 kilograms. Let's see what is next. The cyclists come to a hill inclined at 2 degrees to the horizontal. Okay, let's say this is the hill and it is inclined at 2 degrees. Okay, when the cyclist starts to climb the hill, he increases the power to 300 watts. Okay, the resistance is still 20 newtons. Show that the steady speed up the hill which the cyclist can maintain when working at this power is this. Correct to 3 signal figures. So he is trying to take the bicycle upwards, so he is applying applied force. There is a resistance force of 20 Newton, which includes air resistance and friction. But there is one component of the weight. His weight is 80 kilogram now, bicycle and the person. So the weight downwards will be 800 newtons. That's the always towards the center of the earth. And the component in this direction, which is resisting this motion, is 800 sine 2 degrees. These are the two resistive forces this applied force has to overcome. So let's find applied force first, and then we can find the speed. So MA equal to applied force minus resistive force. That's what we did in previous part also. Mass we know is 80 kilograms. Acceleration is 0. How come? Because they said steady speed. When speed is constant, acceleration is 0. So we'll put 0 here. Applied force we want to find out. Resistive force, we have two of them, 20 Newton, and we'll subtract both of them, okay, because both of them are in opposite direction of applied force. 800 sine 2 degrees. Right? So now this will be 0, and let's bring those two here, so they can become 20 plus 800 sine 2 degrees equal to the applied force. Now they want us to find the speed, show that this is the speed, 6.26. So the previous part also we used the formula that power is equal to applied force times speed, or applied force is P over V, right? But this time we have to find the speed. So we will write V equal to P over applied force, right? Power is known to us. So speed will be, power is known to us, 300 watts. Applied force we know now, divide by 20 plus 800 sine 2 degrees. Put this carefully in a calculator and you'll definitely get 6.26 meters per second that they want. Let's move on to the next part of this question. Find the acceleration at an instant when the cyclist is traveling at 90% of the speed in part 2. So in part 2 we got 6.26 meters per second, right? So we want 90% of this. So 90 multiplied by 6.26 equal to, I get 5.634 meters per second. This is the speed. They're asking the acceleration. So again we will use the same formula, ma equal to applied force minus resistive force. So now the resistive forces are 2 again, so we'll write both of them. Mass was 80 kilograms for the bicycle and the girl. Acceleration we want to find out. Let's talk about applied force. Applied force will be, the power is 300, same power, but the speed now is 5.634, and this gives us 53.8 25, almost this force. So 53.25 is the applied force, minus resistive forces were 20, and then we had 800 sine 2 degrees. So acceleration will be this whole thing, let me write the whole without solving it, minus 20 minus 800 sine 2 degrees, and we divide both sides by 80. So I divide this side also by 80. Cancels here, and acceleration we get is 0.0666 meter per second square. Let's move on to the next part. A box of mass 50 kg is at rest on a plane inclined at 10 degrees. Okay, so this is the plane which is inclined at 10 degrees, and this box is at rest. Its weight will be 500 newtons this way, because mass is 50 kg times 10, 500. Find an inequality for the coefficient of friction between the box and the plane. Is it moving? At rest. Yes, it is at rest. That means there will be a component of this weight downwards, which is 500 sine 10, but it is not moving because friction is stopping it from moving downwards. That means both the forces are equal. So we will write frictional force is equal to 500 sine 10 degrees. But they want an inequality. That means frictional force is definitely more than 500 sine 10 degrees, or maybe equal to, maybe it is about to move, we don't know. So frictional force is more than or equal to 500 sine 10 degrees. Now, they are saying inequality for coefficient of friction. That means we have to break this frictional force into its formula, which is mu times normal contact force is greater than equal to 500 sine 10 degrees. Alright, so we should know the normal contact force first. And normal contact force is 90 degree to the surface, which is here, which is always equal to the component of the weight in this direction, which is 500 cos 10 degrees in this case. So same will be the R, and that's what we will write here. Mu times 500 cos 10 degrees is greater than equal to 500 sine 10 degrees. So mu will be greater than equal to, if you divide both sides, we'll get 500 sine 10 degrees over 500 cos 10 degrees. 500 and 500 cancel, and cos sine 10 over cos 10 will be 0.176. That's the inequality for coefficient of friction. In fact, the coefficient of friction between the box and the plane is 0.19. It is more than 0.16. Okay. So mu is 0.19. The girl pushes the box with a force of 50 newtons. So force applied by her is 50 newtons. Acting down a line of down. Okay, she is pushing it down. So force applied is downwards. Besides, there is a weight of 500 Newton for the box. So its component in this direction will be 500 sine 10 degrees, because this is 10 degrees, right? Alright, that means friction will be in this direction. Okay, down the plane for a distance of 5 meters. So distance is 5 meters. Then she stops pushing. Okay, she pushes it for 5 meters and stops. Use the energy method to find the speed of the box when it has traveled further 5 meters. Okay, these 5 meters and plus 5 meters without applied force. Without applied force. Alright, and they're asking us to use energy method. So the energy method is delta KE plus delta PE is equal to applied force work done by this and minus work done by resistive force. All right, let's focus on delta KE first. Delta KE is half times m final velocity, which they are asking actually initial velocity, right? And that's what we'll prove here. We'll just replace them. Half mass of the box is 50. Final velocity, let's write it v square because initial velocity is rest. It started from rest. So this is done. Let's do delta PE. Change in potential energy is mass times g times final height minus initial height. So m is 50, g is 10, so 50 times 10 will be 500. The height change, total distance it traveled was 10 meters, yeah, 5 meters the goalpost and 5 meters further it went. So let me try to understand this here. If the box traveled 10 meters in this direction, this is 10 degree, this is the height change, correct? And that is down, means it will be a negative height change because later it is at lower level than this one. So h over 10 equal to sine 10 degrees. So h becomes 10 sine 10 degrees. This is the height change. And I will use 10 sine 10 degrees here. Okay. So it was 500 and now minus 10 sine 10 degrees is the height change, minus negative. All right, applied force works. She worked for only 5 meters. So any work done is 50 multiplied by 5. The force applied multiplied by the distance traveled. 4 times distance is work done. Let me write it here. Yeah, and that's what I've done. Applied force is 50 and it traveled 5 meters with that force. Minus work done by resistance, but the friction worked the whole 10 meters. So what is friction? Let me write here. Friction is mu r. Mu is 0.19. R is the contact force in this direction, which is 500 cos 10 degrees. Why? Because the component in this direction is the same and there is no motion in this direction. That means this force will be equal to the this y component of 500 newtons. So that's why it will be 500 cos 10 degrees. All right. So here it is 0.19 times 500 cos 10 degrees and it went for 10 meters. Again, this is the force of friction multiplied by the distance it worked. It worked for 10 meters. Now we can simplify all of them. 2 and 25. 25 v square minus 500 times 10 is 5000 sine 10 degrees. 50 times 5 is 250 minus 10 0.19 times 500 times 10 90 950, yeah, 950 cos 10. Okay, so V is the target we want to find out. So let's write it here. 25 V square equal to 250 minus 950 cos 10 plus 5000 sin 10. Let me evaluate this. 25 V square equal to, let me put this in my calculator and let you know. By the time I do this, I would request you to subscribe to my channel and like, share this video with your friends. And if you have any request for any solution video, I'll prepare for you. And this is how we will have the best use of knowledge. Okay, when I put this thing in my calculator, this whole thing, I got 182.767 actually, but I'm writing it 7 to save space. So V square will be 182.7 over 25 which will be 7.7 point v square equal to 7.306, and if we square root both sides we get v equal to 2.7 meters per second. Okay, the next one. The box then comes to a plane inclined at 20 degrees now. Not 10 degrees, 20 degrees now. Okay, so this is little higher than the previous one, 20 degrees. So it will try to go down by itself, and same 500 sine 20 degrees will be the force downwards, and the box moves down line of greater slope with this force. The coefficient of friction is still 0.9 and it will work in this direction, friction. Okay, girl is not pushing the box, so there is no more extra applied force. Find the acceleration of the box. Okay, so we know MA equal to applied force minus resistive force. Mass of the box is 50. Acceleration they are asking equal to applied force is 500 sine 20 minus resistive force is 0.19 times 500 cos, this time 20 degrees. This is the resistive force, which is actually the force of friction. So acceleration is 500 sine 20 minus, let's do this again, 95, yeah, cos 20 divided by 50, yeah, this 50. So let's put this in our calculator and let's get the acceleration. I'm getting 81.74 over 50, which is 1.634, so 63 meters per second square.